Let's consider how call prices and put prices change as the strike price changes. And I do want to point out that we are looking at the strike price here and not the stock price. Oftentimes we're interested in how call options and put options prices change as we change the stock price, but in this case we are talking about changing the strike price for those options, not the stock price. Well, the first thing we notice is that for a put option, if we increase the strike price, then we're going to increase the value of the put option. And we can see that here because the graph is upward sloping. And that makes sense, doesn't it? Because if we increase the strike price for the put option, that's a value that we may eventually be receiving. A put option gives us the right to give up the underlying asset and get the strike price. So being able to get a higher strike price makes a put option more valuable. That's why it's upward sloping. On the other hand, for a call option, we pay the strike price and receive the underlying asset. So potentially paying the higher strike price is going to make the value of the call option decline. Now this concept is called Proposition 1, and it's the first statement shown down below here. Next, let's consider Proposition 2. Suppose that we have a put option, and suppose that we start at the strike price that's shown right here. And now someone comes to us and says, I could increase that strike price by $1 so that the strike price would move from this first dotted line to the second dotted line. If they were to do that and I owned the put option, I would be glad they did that because I could potentially be receiving that strike price. So I would even be willing to pay them some amount of money to increase the strike price by $1. But would I be willing to pay them an entire dollar? The answer to that question is no, I would not, because I'd only be potentially receiving the extra dollar from increasing the strike price. It's entirely possible that the put option is going to expire out of the money, in which case, even with the higher strike price, I'm still not going to receive anything. So here we see we're increasing the strike price. I'm saying it's by $1. It doesn't really matter what amount, but we increase it by $1, and over here you can see that the increase in the value of the option premium is less than $1. We have the same sort of situation then with a call option. So if we started with a strike price over here and someone offered to decrease the strike price by $1, we would certainly appreciate that if we owned the call option because we may be potentially paying the strike price. And so we would pay something to have that strike price decreased by $1, but would we pay a whole dollar? The answer is no, and we can see that right here that the decrease in the value of the strike price is larger than the associated increase in the value of the call option. Next, let's consider the third proposition down here, which tells us that the slope is increasing for both the call option and the put option. Well, first, with the put option, here's our slope at the lower strike price, and here's a steeper slope at the higher strike price. That's suggesting that down here at the lower area, if I increase the strike price by $1, there will be an associated increase in the value of the option, but it won't be as large as the associated increase in the value of the put option if I increase the strike price by $1 when the strike price is currently quite high. Now why is that? Well, when the strike price is quite high, the put option is much more likely to be in the money. And therefore, although it's still true that the slope is going to be less than 1, the slope may start to approach 1 as the strike price becomes very high. Now let's consider what happens when we look at the call option. Over in this area here, where the strike price is fairly high, it's less likely that the call option is going to expire in the money. If we have a lower strike price, then it's more likely that the call option will expire in the money, and therefore decreasing the strike price by $1 for a call option provides greater value when the strike price is lower, because it's that much more likely that that extra dollar is actually going to benefit the owner of the call option, because it's that much more likely that the call option is in fact going to be exercised. Sometimes people look at these lines for the call option and say it doesn't look like the slope is increasing because it looks like these lines are becoming less steep as we move forward with the strike price. But remember that the slope here is a negative value because these lines are downward sloping. And so what we see as the strike price increases, the slope is becoming less negative. And another way of saying that is that the slope is in fact increasing. We're sometimes going to use spreads to describe a strategy that potentially allows us to earn arbitrage. So let's take a moment here to understand what spreads are. The first thing to know about spreads is that we're buying or selling calls or puts that have different strike prices. And it is calls or puts. So that is to say that a bull spread or a bear spread or a butterfly spread, each of those would either consist of calls or it would consist of puts, but it wouldn't consist of calls and puts. Well, let's start with the bull spread. A bull spread is going to have a payoff that increases when the price of the underlying asset increases. So if we were speculating, we would typically purchase a bull spread if we expect the price of the underlying asset to go up. To construct a bull spread, we will buy the low strike option and sell the high strike option. And this is going to be true regardless of whether we're dealing with calls or puts. On the other hand, if we're constructing a bear spread, we're going to buy the high strike option and sell the low strike option. And in that case, we're going to have created a payoff that will increase when the price of the underlying asset decreases. So if we were pessimistic about the price of the underlying asset, that is, that we think the price of the underlying asset will go down in value, if we were speculating, we might enter into a bear spread. A butterfly spread makes use of three different options. And we would purchase the low strike option, and we'd also purchase the high strike option, and we would sell the option with the middle strike price. For a butterfly spread, the quantity of options purchased is equal to the quantity of options sold. And furthermore, the average strike of the purchased options is going to be equal to the strike of that middle option that is sold. Suppose that we have purchased one call option with a strike price of 5 and 5 call options with a strike price of 11. And we're seeking to create a butterfly spread. So we've already purchased the options. We know we're going to be selling an option with the middle strike price. We don't yet know what that middle strike price is. We do know, though, that the average strike price of the options purchased has to equal the strike price of the option that is sold. So let's calculate the average strike price of the options that we've purchased. We just take 5 times 11 to get 55, and then we add in 1 times 5, which is 5. We add that to the 55 to get 60. And then we have 6 options total here, because 5 plus 1 is 6. Take the 60 divided by the 6, and we see that we have an average strike price of 10. So the option that is sold has a strike price of 10. And how many of those options do we sell? Well, we said the quantity of options purchased is equal to the quantity of options sold, and therefore we sell 6 of the 10 strike call options. The butterfly spread in this example here is an asymmetric butterfly spread, because 10 is not exactly in the middle of 11 and 5. According to Proposition 1, the value of a call option goes down as the strike price increases. To illustrate this point, we're going to make use of 3 strike prices that are shown down below here. We've got K sub 1, which is less than K sub 2, which is less than K sub 3. Now in this particular slide, we're just going to make use of K sub 1 and also K sub 2, but later we're going to use K sub 3 as well. So K sub 1 is a low strike price, and relative to K sub 1, K sub 2 is a high strike price. For the call options, Proposition 1 is telling us that the call option with the low strike price must have more value than a call option with a high strike price. Now what if this proposition were violated? That is, what if we had a less than sign here instead of this greater than or equal to sign? Well, in that case, the proposition would be violated because the low strike call option has less value than the high strike call option. Another way to say that is that the low strike option is too cheap, and that's what's making our proposition be false. Well, if the proposition is false because something is too cheap, what we want to do is buy the thing that is too cheap. So we'll buy that low strike option, and then we'll sell the high strike option, and that will generate arbitrage. Now let's take a look at the put options. For a put option, as the strike price increases, the value of the put option increases as well, because the put option gives us the right to potentially obtain the strike price. So going down here then, we see that the value of a high strike put option is going to be greater than the value of a low strike put option. Now what if this proposition were violated? That is, what if we had a less than sign here? Well, in that case, the value of the high strike put option would be too low, or we could say that the high strike put option is too cheap relative to the price of the low strike put option. So let's buy the thing that's too cheap, which is the high strike put option, and let's sell the thing that is too expensive, which is the low strike put option. On the preceding slide, we said that if Proposition 1 is violated for call options, then we want to buy the low strike call option and we want to sell the high strike call option. Buying the low strike option and selling the high strike option is constructing a bull spread, and in this case we're dealing with call options, so we're going to refer to this as a call bull spread. Now let's think about what it's going to cost us to enter into this call bull spread. Well, if proposition 1 is violated, the low strike option actually is less expensive than the high strike option. That is, we're going to receive more for selling the high strike option than we will have to pay to buy the low strike option. Therefore, we're going to be paid to enter into this call-bull spread. Well, that's good so far. We haven't had to pay any money out of pocket, so this strategy is looking attractive. But what about what's going to happen in the future? What is the payoff of this strategy going to look like when these options mature? Well, that's going to depend on what the stock price is when the options mature. And let's take a look here. Well, first of all, suppose the stock price is less than the lower strike price. Well, in that case, both call options expire out of the money and there is no payoff at all. Now, on the other hand, if the stock price exceeds the lower strike price, then we own the call option with the lower strike price, and therefore, for every dollar that the stock price is higher than the lower strike price, we're going to receive an extra dollar of payoff. And that will continue right up until we reach the higher strike price. When the stock price reaches K sub 2, then we have to pay out $1 as the stock price continues to rise because we sold the call option with a strike price of K sub 2. We still own the call option with a strike price of K sub 1, and so we receive an extra $1 as the stock price continues to increase, and we have to pay out $1 as the stock price continues to increase, and we net out with the payoff just remaining constant as the stock price exceeds K sub 2. So what we see here is that it's possible for the payoff of this strategy to be 0. It's also possible for the payoff of this strategy to be positive. The cost of this strategy to us is actually negative. That is, we're being paid to enter into this call-bull spread if proposition 1 is violated, and we're sure to receive a payoff that is at least 0 and quite possibly positive, and therefore we're quite willing to do this if proposition 1 is violated. That is, we're quite willing to enter into a call-bull spread. We said that if proposition 1 is violated for puts, then we want to buy the high strike put option and sell the low strike put option. Buying the high strike option and selling the low strike option is equivalent to establishing a bear spread. And in this case we're dealing with puts, so we're going to refer to this as a put-bear spread. If proposition 1 is violated, in that case the high strike put option has a lower price than the low strike put option, and therefore we're going to be paid to enter into this put-bear spread as long as proposition 1 is violated. Now let's take a look at what the payoff is going to be when these options are exercised. Well, if the stock price is greater than K sub 2, then both of these put options are going to expire out of the money, so the payoff will be 0. If the stock price is less than K sub 2, then we have the option that we own, that is the high strike put option. That's going to have a positive payoff, and that payoff will increase for every dollar that the stock price falls below K sub 2. However, once we reach K sub 1, then we have to pay out $1 because we sold the low strike put option, and since we have to pay out $1 and yet we still continue to receive $1 from owning the high strike put option, the payoff levels out. We can see that the payoff is either going to be 0 or it's going to be some positive amount, and as we said, we're paid to enter into the put-bear spread if proposition 1 is violated, so we're quite willing to enter into this put-bear spread if proposition 1 is violated. Proposition 2 is that the absolute value of the slope is less than or equal to 1. Equivalently, we can say, as we do down here, that the change in the value of the call option is less than or equal to the change in the value of the strike price. Now let's suppose that that proposition is violated. That is, instead of having a less than or equal to sign here, we have a greater than sign. And in fact, let's just go ahead and show it here. Now I've got it in red because this is not the proposition, this is the violation of the proposition. Why are we violating the proposition? Well, it's because the side on the left here is too high. And that means that this first call option, the one with the low strike price, is priced relatively high compared to the price of the high strike call option. So what we're saying here is that the low strike call option is relatively high, the high strike call option has a price that's relatively low. That tells us now how to implement our arbitrage strategy. Let's buy the thing that is priced too low, and let's sell the thing that is priced too high. And so there's our arbitrage strategy. Now let's take a look at the put options. If the absolute value of the slope is less than or equal to 1, we can equivalently state that as saying that the change in the value of the put options has to be less than or equal to the change in these strike prices. Now, if this is violated, that means that we have a greater than sign over here where we see the less than or equal to sign. So again, I'm going to show this violation in red. It's not the proposition, it's a violation of the proposition. And let's take a look at what we have here. This left side is too great, and that means then that the price of the high strike option is relatively too high and the price of the low strike option is relatively too low. And so let's sell the option that's priced too high, and that's right here, and let's buy the option that is priced too low, and that rule shows us then how to construct an arbitrage strategy. If proposition 2 is violated, then we're going to buy the high strike call option and sell the low strike call option. When we buy the high strike option and sell the low strike option, we're creating a bear spread, and in this case we're dealing with call options, so we're going to call this a call bear spread. Well, now let's think about what the payoff of this bear spread is going to be. If the stock price is less than K sub 1, then both options expire out of the money and the payoff is 0. Now if the stock price exceeds K sub 1, then the call option with the K sub 1 strike price is going to be in the money. But remember, we're short the low strike call option, so as that becomes in the money, then the payoff is negative for us. Now that will continue until we reach the strike price of K sub 2 because we are long the high strike call option, and so when the stock price exceeds K sub 2, we receive an offsetting payment as the stock price increases, and therefore our losses level out to be at the maximum the difference between K sub 2 and K sub 1. Now what does it cost us to enter into this call bear spread? Well, in this case it doesn't actually cost us anything. We would be paid to enter into this call bear spread because we would receive this amount here, the value of the low strike call option, and we would have to pay out the cost of the high strike call option. That is, the amount that we receive is C of K sub 1 minus C of K sub 2. Well, we know from the preceding slide that if proposition 2 is violated, that amount we're going to receive will be at least K sub 2 minus K sub 1. And this is what makes proposition 2 work. There's really no chance of a loss to a strategy like this because we're going to be paid up front more than we could possibly lose. For puts, if proposition 2 is violated, then we buy the low strike option and we sell the high strike option. Buying the low strike option and selling the high strike option is creating a bull spread. And in this case, we're dealing with puts, so we're going to refer to this as a put-bull spread. Let's consider what the payoff is now. So we've purchased the low strike option and we've sold the high strike option. As we consider the payoff with put options, I always like to come from the right side. It's just a little bit easier to see because as long as the stock price is greater than K sub 2, the payoff to both of the put options is going to be 0. Alright, well now that we've reached K sub 2, if the stock price falls any further, the high strike put option is going to go into payout status, but we are short that high strike put option, and therefore that results in a negative payout for us. Then as the stock price continues to fall, we get the positive payments kicking in from the fact that we purchased the low strike put option, which has a strike price of K sub 1, and our losses then stabilize to K sub 1 minus K sub 2, which is shown right over here. If we implement this strategy, we're selling the high strike option and we're buying the low strike option. Consequently, the amount that we're going to be paid to enter into this strategy is P of K sub 2 minus P of K sub 1. And if proposition 2 is violated, we're assured that that quantity is greater than or equal to K sub 2 minus K sub 1. Said differently, we're being paid up front at least as much as our maximum possible loss, and therefore we're quite willing to enter into this strategy if proposition 2 is violated. In general, propositions 1, 2, and 3 apply for American options, and they also apply to European options. However, for proposition 2, we can create a special version that applies just to the European options. Remember that we described proposition 2 by saying that if we're paid the difference between these strike prices up front, then we're sure to be able to tolerate a loss that is guaranteed to be no more than the difference between the strike prices. Well, if we take into account that for European options, we know that the exercise won't occur until time capital T, well, in that case, that payment that needs to be made to us can be as little as just the present value of the difference between the strike prices. And this works for the call options and also for Proposition 2 for the put options. So now we have a little bit more restrictive Proposition 2 for European options. In this question, the first four statements shown at the top are just describing the notation that we're going to use for this question. The real meat of the question is contained in the bottom portion, where we see three different statements, and we are asked which ones are correct. Each statement contains two inequalities, and for the statement to be correct, both inequalities have to be correct. Now for statements 2 and 3, there's a little bit of a trick to get through the logic of whether or not these statements are correct. And that trick is to make use of put-call parity. I'll repeat statement 1 in the upper right-hand corner of the screen here. It's shown above here in blue. That way we have it to reference as we work through this problem. Well, from Proposition 1, we know that when we increase the strike price for a put option, that put option becomes more valuable. That's what we're showing right here. And now just putting in 75 for case of 2 and 70 for case of 1, and then rewriting it a bit, I can see that the difference between the put option with a strike price of 75 and the put option with a strike price of 70 is in fact going to be greater than or equal to 0. And so right here we can see that that first inequality is true. Now, we know that when we increase the strike price from 70 to 75, the value of the put option goes up, but it doesn't go up by any more than 5. And in fact, this question had European put options, and therefore we can say that the value of that put option will not go up by any more than the present value of 5. And 5, of course, is the difference between 75 and 70. So over here we have the present value of 5, and therefore from Proposition 2 we know that this inequality is true as well. And I've shown that down here where I repeat Proposition 2. So now we can see that Statement 1 is in fact true. Next, let's show Statement 2 here again, and I've shown it here in blue. So now we have Statement 2 that we need to evaluate, and we're going to start by evaluating this less than or equal to sign right here. And the way we're going to do that is we're going to make use of put-call parity, which I've reminded us with this expression right here. That's just our standard expression for put-call parity. If I take the call option here and subtract it from both sides, it looks like it's in slightly different order, but I have something that looks like this, don't I? I have the put option minus the call option plus the stock price. So here I have the stock plus the put. I'm just bringing the call option over to the other side. And now let's again look at this inequality on the left. What if this were an equal sign instead? It would in fact be an equal sign, wouldn't it, if we changed this 70 right here into 65. And that's what I'm showing down here, where I've taken the 70 and replaced it with 65, allowing me to replace the inequality with an equal sign. Alright, but in reality what we have is 70. We don't have 65. So we replace it with 70, and what happens then? Well, the value of the call option goes down when we replace it with 70, and we're subtracting out a smaller amount, and that means that we have to replace the equal sign with a greater than or equal to sign. And therefore, we have just shown then, with this expression right here, we have shown that this inequality up above is in fact true. Once again, I'm going to repeat Statement 2 in blue, and this time we're going to take a look at this inequality right here. Once again, we're going to make use of put-call parity. As we look at this, if we had this 65 right here replaced with 70, then we would have an equal sign right here. And that's what I'm showing down below here. But we don't have 70 here, we have 65. And because we have a lower strike price, we're going to have a put option that has a lower value. Therefore, instead of an equal sign here, we need to replace it with a less than or equal sign when we use 65 instead of 70. And what we've shown with this expression right here is that this inequality up here is true. Since we've shown that both inequalities for Statement 2 are true, we've shown that Statement 2 is true. Now let's take a look at Statement 3, and I've repeated it over here in blue. And the first thing we want to notice about Statement 3 is that the middle portion here is exactly the same as the middle portion that we saw in Statement 2. And that's going to make the evaluation of this first inequality pretty simple. Up above, we said that that middle portion has to be less than or equal to the present value of 70, and therefore it is not the case that it is greater than or equal to the present value of 70. Now, the second inequality is true, but statement 3 is still going to be false. The reason we know that the second inequality in statement 3 is true is that we're told that this portion in the middle has to be less than 75, and we already know from statement 2 that it has to be less than the present value of 70, and certainly the present value of 70 is less than 75. Therefore, that second inequality is true. But statement 3 is still false because the first inequality is false. Choice D is the correct answer.